tutorial. Okay, if you don't have, also fine. Okay, tutorial, but I think you guys need it. Okay, you guys need it as a student at first year, second year. You guys need it. Okay. So, without further ado, so we're going to go to Signals and System, Chapter 2, Fourier Series, Part 1. Okay. So, if you guys notice, I have shared to you the lecture for the asynchronous on the Thursday. Okay, on the Thursday. I mean, that's supposed to have, that you're supposed to have on last Thursday. Okay. So, you can see at the at e-learning. And secondly, I will not be lecturing about I will not be lecturing about convolutions. Okay, I will share the slide and on convolution. Because this I asked the coordinator. Okay, this part is not teach. Okay, convolution, and it's not accessed in the test and the final or even quiz. It will assess using group assignment. So hopefully, my session with whole lot student right now, I hope that no more incoming, because I need to divide you guys in group to do project assignment. Okay, project assignment, group assignment on convolution. Okay, I will share the lecture slide in the e-learning about convolution, and I will share the task. Okay, later on. So that's why you suddenly have chapter 1 part 1, chapter 1 part 2, and chapter 1 part 4, but you didn't have chapter 1 part 3 lecture. Okay, this one is about convolution. Okay, now we go to the chapter 2. Okay, so since I'm still this in the group discussing about the sudden no class. Okay, so type of signal. Okay, if you see our signals, okay, in life we have signals in the time domain. Okay, we see here we have this variation. Wait for I share the screen. Okay, so you have this variation of analog continuous in time domain, and you have another signal which is also in the time domain. And let's say, for example, you have three signal in time domain here. Okay, you see, just like a story about the blind people. Okay, group of blind people trying to visualize how elephant look like. Okay, some touch the ear, then they say it's thin, something like that, and touch the body is big, and touch with the tusk, and saying it's pointy, gading gajah. Okay, so but they trying, all of them trying to visualize how the elephant look like. So it is how you visualize something from different view. All the while you visualize signals from the from here, this one view, time domain. But there is another view that we can view these signals is in the frequency domain. So we will study on the frequency domain here. Okay, so you can see this is from different view. If from this view you see like it is a straight. Okay, okay. So we will study about outline for today is sinusoidal signal, Fourier series, effect of Fourier series characteristic. Okay. So I will see how long I will present, since we already lost some like 30 minutes of the lecture today. So this is UTM wallpaper. I take it from Facebook, the new one. So it's look nice. Okay, so sinusoidal signal is a signal expression. Okay, it is in the time domain graph. Okay, time domain, just like I showed you guys just now. And then frequency domain spectrum, exponential phasor representation, complex exponential representation, periodic signal. Okay, so this is the signal expression. Okay, sinusoidal signal is a common type of signal used in various systems. So consider a very time varying voltage signal. Time varying voltage signal. You can see this is V voltage and this is inside T, means it is varying with time. We is dependent, time dependent signals. So A naught is your amplitude of the sinusoids, and you have omega naught here is your angular frequency. This is theta naught. This is a phase shift here. Okay, as you learned that before, right? This is shifting. Then this one you also learn where H is omega is actually 2 pi f. Okay, 2 pi ft. Then if you introduce some shift, it's like for example this one is pi over 2. Okay, so can be written as sine omega t naught plus theta, but with a difference of pi over 2. Okay, so this is in cos, but this is in sine. Okay, I think this is mathematically you can relate, compare between cos and sine. Okay, between cos and sine. Sine, it will be delayed by, it will delay by pi over 2. Okay, pi over 2. You see here, first is you see a sine, whether delay or advance we see. Okay, this is sine 2 pi f naught t. Okay, and then if you want to convert to cos, you have to add another shifting here. So from 0 to minus pi over 2. So from sine, it is a bit delayed. Okay, a bit delayed um, by pi over 2. Okay, then you change it to cos. Okay, I think you can actually see it from the graph. Wait. Oh, I think you can see from the graph of cos and sine. What is the different? Okay, like this. Okay. So time domain signal. If you see, this is the sine graph, okay, and then you have the cos graph here. When the cos graph, you have actually curve from here, okay. So there is a difference of what, lambda pi over 2, 90 degrees. So that's why there is a difference of 90 degree. Whenever you convert from sine or cos to sine, you need to consider this phase shift, okay. So consider a time varying voltage signal. You can see, I think this one you already familiar with. T, the complete period is actually 1 over f naught, okay, equals to 2 pi over omega naught, okay. T is the complete period, f is the frequency, okay, and then this angular frequency. Okay, this one have been touched in the previous lecture, okay. Frequency domain signal spectrum. Okay, frequency domain signal. Now we look into frequency domain signal, which is a spectrum. Spectrum is actually the signal represented as in a frequency domain, just like how we visualized the elephant just now. So each sinusoidal signal has a frequency f, amplitude a, and phase theta. Okay, amplitude and phase can be plotted with frequency to produce spectrum signal. Example, A1 cos 2 pi f1 t plus theta 1 plus A2 cos 2 pi f2 t minus theta 2. So actually when we want to represent our signal in the frequency domains, okay, so you can see we will have an amplitude spectrum and we will have the phase spectrum. This is single-sided spectrum. We call it single-sided spectrum because we only have one side here. We don't have the negative side here. So this one is a single-sided spectrum, amplitude spectrum and phase spectrum. So if you see, this one is A1 cos 2 pi f1 t plus theta 1. So A1 cos 2 pi ft. So you can see this one is 2 pi f1 is actually equals to omega 1. So here, so it is here omega 1, and then with amplitude of A1. Okay. and the phase shift of theta 1. So positive theta 1. So you have theta 1 here. Okay. Another one, A2 here, A2 at 2 pi F2, which is omega 2. So located here as your A2. This one is for the amplitude. The similarly go for this phase spectrum, because you have negative here, you will have negative theta 2. Okay. If you don't understand, please ask. Where is my pen? Okay. So the example here, okay, example, plot the amplitude spectrum and phase spectrum for signal below. Okay. So Vt A cos omega naught minus B cos 2 omega naught t plus C sin 3 omega naught t. Okay. First of all, when you see this question, you see a mixture of cos and sine. Okay. So when you see this kind of question, you need to convert them. Okay. You need to convert them to have similar. To have similar, either it is all cos or all sines. Okay. So but this question, you can see it is logically you need to convert all to cos. You see the two of them is already in cos, and you need to convert this sine to cos. So this one, you need to see, this is the hint. I think you guys familiar with, hopefully, okay, uh, with this conversion. Negative cos theta is actually cos theta plus phi, and sine theta is actually cos theta minus pi over 2. Okay, so you see, okay, you see this negative cos theta. Okay, so you see here, sin is being convert to cos. Okay, so how we going to convert sin to cos? With additional of phi over 2. Okay, so you guys can practice this example at your own later on. Okay, so you guys just, if you guys have the same answer, then you are correct. Okay, you see A1 at omega naught here is A, and then the next for amplitude spectrum you have B, and the next one is you have C. Okay, so this one is just a representation. Doesn't mean that A is actually higher than B, because we don't know the value yet. Okay, we don't know the value yet. We just give it A, B, C, something like that. And then for the phase spectrum, okay, we can see that for here, A cos omega naught t, there is no phase shifts. That's why you have 0 here. Okay, you have 0 here. And then next you have pi. Okay, at 2 omega naught, you have pi. And then at the next 3 omega naught, you have negative pi over 2. Okay. Where is it just now? Okay, this one. Okay. Okay, this is what. Okay, consider this is a naught cos omega naught plus bn sine omega nt. So now you have omega n here. Okay, you have omega n. So you need to be sure when you answering question later on, you need to write it properly. Maybe you get used to omega naught, then you write it omega naught, but question is actually omega n. So be careful of whatever you rewrite, because in the exam sometimes, I think I'm a student also. When we're nervous, we write something that is wrong, okay, mistakenly. So you see, this is omega n. So if you see this condition, a not a n cos omega nt plus bn sine omega nt. So now we are trying to combine. We are trying to combine both of these to become like this one. Okay, to become a combination. Okay, so you can see these two a n and bn can be combined, become one. Okay, so with this kind of equation, where you have a n equals to a n square plus bn square. Okay, provided they are sharing the same omega n, okay, they are sharing the same omega n, okay, then you will see that this a square plus b n square, okay, to actually have your amplitude an. So you here is the resultant amplitude an, okay, and the theta n, the shift is actually tangent, inverse tangent of negative, you can see it's negative of bn over an. Then you get your phase spectrum, okay. Sinusoidal signal can be shown as x-axis or y-axis projection by an anti-clockwise rotational phasor. Okay, this is for phasor representation. I think you guys familiar, maybe learn a bit during your secondary school. I'm not sure with Indonesian syllabus or the other foreign country syllabus. Sorry, but for us, Malaysian syllabus, we have some sort of uh, learn about phasor, but maybe not that detail. Okay, just a bit. Okay, so sinusoidal can be shown as x-axis or y-axis projection. Okay, by an anti-clockwise rotational phasor. So anti-clockwise, so it is moving here. Okay, and you can see for phasor representation, the x-axis is the real term and the y-axis is the imaginary terms. So this is the rotational. Okay, starting from here. Okay, and this is your amplitude of a naught. Okay, uh why is there is sorry, I see there is my name here. Do you guys see it? Remove Remy presentation from the call. Do you guys see this?
Still
Do you guys see some wording there? Remove Remy from presentation. Is this? Do you guys see
no,
this?
no.
No. Okay, no means only me see it. Okay, okay, don't worry, don't worry. Because I see some disturb. Okay, I see something like this. Okay, you guys can see for WhatsApp, I saw that just now in our, I still see that. Okay, so this is how you going to represent it is in a phasor representation. Okay, now we go to complex exponential representation. So you see in is used to analyze a signal. This complex exponential, in general, we know about this VT and naught cos omega t plus a naught theta naught. So if we want to represent it using exponent, okay, so means that you will have exponent terms, okay. So they you need to learn about Euler's theorem, okay. I think Euler's theorem it is I'm not sure whether it's provided in the table of the exam. I think maybe okay. I didn't check yet. Okay, so but this is I think it is why it is better for you guys to actually memorize. Okay, to actually memorize this because later on you'll be using this often. Okay, this Euler theorem. Okay, Euler theorem state that E j theta is actually equals to cos theta plus j sine theta. Okay, in exponent representation, you have cos theta t equals to ej theta t plus e negative j theta t over 2. Okay. And you have the counterpart for sin. So the only difference with this is actually for sin, you have 2j. Okay. So you have to bear in mind the difference between cos theta t and sin theta t. Okay. Is this one with a j. So this is actually, if you want to convert from general form to the complex exponential representation. Okay, so you will use Euler's theorem to convert. So you see, this is time domain polar form, the general form, a naught cos omega t plus theta naught. Okay, if you want to convert into the exponent complex exponential form, you will have to convert this cos omega t plus theta naught. Okay, you see here cos omega theta t. So okay, so how to convert? You will actually change this one. Okay, you use this formula to change. So cos omega t plus theta naught, okay, is actually this one ej. Then you will change. Okay, you will change whatever inside here. You change whatever inside here with omega t plus theta naught. Okay, as one element, as one group, and then the next is negative omega t plus theta knots. Okay, that's why you have this, and then this two is being brought to here. Okay, so that's why this is your complex exponential form of the time domain or polar form, or the general, or we can call it as a general form. Okay, I think this is quite straightforward. Okay, you just put it inside. Okay, put it inside, substitute accordingly for this. So this is the from the example just now. Okay, from the you have for vt a naught cos omega t plus theta naught, then you have this. Then we're going to represent our graph accordingly based on this complex exponential representation. So this is the time domain. Okay, time domain polar representation. Okay, the same graph polar representation where we have real and imaginary. The same for exponential representation. Okay, so let me look at the time domain polar representation first. Okay, for the real, I'm not sure if it's clear or not. Okay, I hope it's clear. So you have this is the real term, a real axis. This is the imaginary axis. So a naught is your amplitude, and your shift is actually omega t plus theta. Okay, this is your the overall angle. Okay, angular, the overall angular terms. The next is in exponential response. Okay, now you have exponential response. Okay, if you see a naught over 2, now you have two term here. Okay, you have two term here. For, in the time domain, polar representation, you only have one. Okay, you only have one one graph here. Okay, then you have in exponential, however, you have two because now you have two term here. Okay, you have two term here. Okay, that's why you from 1 to 2. Okay, and you can see the magnitude is actually divided by 2 now, divided by 2, and with the angular difference of omega t plus theta for this one, and the next negative omega t plus theta for the clockwise direction. Okay, you can see it's almost the same, just you divide by 2 and with the angular difference here. Okay, this one is theta cos omega t plus theta. Okay, here. Okay, next is exponential form double-sided spectrum. Okay, the signal can be seen as a one function which is generated by two complex components. Okay, the signal can be plotted in amplitude and phase spectrum. Okay, you see two complex component. We have two complex component now. We have two complex component. So we can plot it in amplitude versus frequency, and we can also its phase counterpart need to be plot in terms of phase versus frequency. So this consider this equation, okay, with from general form that we have convert to exponential using Euler theorem. Okay, so this is amplitude versus frequency. You see v naught over 2. Okay, okay, there is a bit mistake in this slide. I will change it later on. This arrow actually, extend from here. Okay, start from the line just like this. Okay, the arrow just like this, start from the axis. Okay, it's not suddenly floating like this. Okay, sorry, because maybe some error when I'm arranging the slide. So I will change this later on. So you see, this is at omega t. Okay, at omega t plus theta, you have v naught over 2, which is here. Okay, and then the next, you have negative j omega. Okay, you have negative j omega t plus theta. It is here. Okay, negative j omega t. So you have v naught over 2 is the amplitude. And then the phase, okay, the phase you can see one is positive and one is negative. Okay, they are the same, but only in difference one is positive and one is negative. Okay, so this is double-sided spectrum. Double-sided, you can see we have both sided. Okay, okay, we have both sided spectrum. You can see from the, when you see my previous when you see this recording lecture later on, you will see that if you, maybe you need to, no, maybe you don't remember what I said earlier. We have a single-sided spectrum. Now we have double-sided spectrum. Why is referred as double-sided spectrum? Because we have the negative value also here. Completes both uh, single-sided and complete both sides of the spectrum. Okay. Next example, frequency domain signal versus exponential form. Okay, both is in frequency, but I mean frequency representation omega. Okay, but we have a frequency domain signal, the, you know, the original frequency domain versus the exponential counterpart. Okay, so you can see the F domain signal, just like we, which is the single-sided spectrum. You can see it's single-sided, and this is your double-sided, where you have double-sided. These arrows also have problem. Okay, I will change later on. Okay, so for A, for the single-sided spectrum, you can see the amplitude is A, and then you have this is theta. Okay, this is the amplitude spectrum, and this is for the phase spectrum. Remember, you see here omega, so the angle should be omega here. Okay, for both amplitude and phase spectrum. Next, when you have this, you convert using Euler theorem, you obtain the exponential form. When you obtain the exponential form, your answer will be in double-sided spectrum. A over 2. So you have both sides A over 2. It's just that one is at omega and the other one is negative omega naught. So if you see this, is just like a mirror, you know, just like a mirror. Mirror, what kind of mirror? Is it time inversion? Is it frequency inversion or amplitude inversion? If you may if you may guess, this is look like what? Inversion, frequency inversion or amplitude inversion for this kind of graph? What do you think? Okay, you guys can give answer at Google Chat. Okay, so this is the phase spectrum. Okay, phase spectrum, you have an omega t and you have negative omega. Okay, so this is your phase spectrum. So this is also should be started from the axis. Okay, I don't know what is the a bit error. I will change later on. Okay, now what is this? Okay, so this is an example. Okay, given a signal gt plus 3.4 cos 10t plus 1.2 cos 10t plus sine 2t 20t plus 40 plus this. Okay, so first represent the signal. Okay, represent the signal in the form of the trigonometric Fourier series, and then sketch the single-sided frequency spectrum. Okay, next is represent the signal in the form of complex exponential Fourier series, and then sketch the frequency spectrum. Okay, so maybe we can try. Let me unshare the screen because I need to transfer to my touch screen. Surya Budi, I don't know why you are scan in attendance with Shafwendra. You guys are different section. You are scanning attendance for SKEU 2073. You should be scanning just now for SEEU 2073. I don't know. I just see this error.
Sorry, doctor.
You are scanning for the other section SKEU 2073 because in your class here you have to SKEU 2073 section 3 and SEU 2073. So Surya, are you Surya? So
Yes.
you are scanning to other section.
But I scanned the one that you shared on the screen.
Yes,
Can,
I'm sharing SKU and SEU, but then I immediately changed to SEU 2073 because I opened SKU 2073 for your friend Wendra to scan, but I think you miss scan to the section.
oh, okay, doctor. Should I
Yeah.
scan again or?
Wait. Let me see if we've already see your name. Shafwendra scan to you. Okay, problem. Shafwendra scan to your section as well. Shafwendra is even funny. He scanned for both section. Okay. Let me wait. Okay. So please scan now. Surya, this is one is your section. Okay. Sorry for the delay of the whole class. Um, so scan now. Surya.
Done, doctor.
Okay. Hmm. Okay, I think now. Okay. So okay, pen. What is the sorry? Where's the lecture just now? Okay, I'm okay. Wait for a while. Okay, so okay. I hope this is clear. You guys need to give me you need to respond using audio because I can now my face is looking at the slide, but I cannot see the Google Chat. Okay, I cannot see Google Chat if there is anything. Okay. So the question is actually given as GT, okay, GT with oh panjangnya 4 plus 3.4 cos 10t plus 1.2 cos 10t plus sin 20t plus 40 degree. Oh ada lagi banyaknya 5 cos 20t plus 40 degree. Okay. So the first question is actually to represent the signal in the form of trigonometric Fourier series and then sketch the single-sided frequency spectrum. So it is actually single-sided. So you will have answer at the only at the positive side, okay, or negative side. Okay, we only have one-sided, but not both side. Okay. So you can see you have sign here, and you have okay, you have one sign here. Mm, is it one sign? Okay. And then you have this cos omega t plus 40. Okay. So this somehow you need to combine. Okay. You need to combine because this one, imagine this one is just now your AN. Okay. And this one is your BN, the smaller one. Okay. The smaller one. So you will use this AN equals to AN square plus BN square. Okay. Like this. And then you can see this is sine is actually an is equals to 1, right? So it's actually okay. We can start here. Okay, sorry, this one is an. If you follow the previous example, okay, I just follow it the same, otherwise you guys get confused. Okay, so this is your an, okay, this is your bn. Okay, I don't want you guys get confused. Okay, so this is your 5. Okay, this is your 5 square plus 1 square, so it will result in how much? I think it's 26. So it is actually 5.1. Okay, 5.1. Next, you try to solve for theta n. Okay, try to solve for theta n. So what actually you learn just now is theta n is actually tangent -1 inverse tangent of your negative bn over an. Okay, so can someone calculate the using calculator for me? Negative bn over n inverse tangent. What you get here? Can someone and then respond using Google Audio, using audio, because I couldn't see chat right now. Okay, so can you guys try to do this? What is the answer? Inverse tangent of to get the theta n. Negative bn is 1. Okay, bn is 1 and an is 5. Anyone care to give answer here? What is the answer here? So I will wait for someone to calculate. I want this section to be active, okay? Not only me doing the talking and I'm not sure student understand or not. Can just respond using Google Audio. I cannot see because I'm my eyes is seeing the slide and also lecturing. Okay, I cannot see Google Chat now. I only have
Negative
2 eyes.
11.3.
Wait, what?
Negative 11.3.
Okay, negative 11.3. Okay, thank you. And remember to put this. It seems simple, but you can lose a mark there. Okay, so this is actually degree. So this is negative 11.3. Okay, next is actually for you to plot the graph. Okay, plot the graph. First you have this is 4. Okay, I use different colors so that you guys can see this is 4. Okay, and then with no angle. Okay, with no angle, so it should be here. I use different color as well, so it is here 4. Okay, it is 4. And what is the angle? Is 0. Okay, here for this 4. Okay, and okay, don't forget this one is amplitude. Okay, and then this one is the angle. Okay, and this one is the omega, angular frequency. Okay, and next we try to see this one. Okay, we try to see this one. Okay, next is 3.4 cos theta t. Okay, cos theta t. Okay, and then you see from here as well. This is actually what? This is actually a combination. So 3.4 plus 1.2 is equals what? Okay, you can add this together because if you notice, they are the same. Cos 10t, this is cos 10t. So 3.4 plus 1.2 is what?
4.6.
4.6. Okay, so another 4.6, a bit higher here. Okay, 4.6. Okay, and then what is the omega? The omega is actually at 10. Okay, omega is actually 10 because you see here, it is the formula is actually omega t, right? So omega here is 10. Okay, so this is 10 here. Okay, so you should have in your angular also 10 here. Okay, but you see there is no angular, there is no shift whatsoever there, so this one should be 0. Okay, should be 0 here. Okay, the next one is you have this now, this term. Okay, but this term sign this one, but you're going to combine. Okay, you're going to combine now. You have an cos, and then 20t plus the theta. Okay, Then what is UAN? UAN now, just now is 5.1. Okay. And then cos 20t. Okay. Now you convert 20t. You combine, right? Just now you combine cos and sine together. And then the theta is what? Theta is 11.3. Okay. So then your graph will be at 20t. Okay. This is your omega. Okay. So it is at 20t. 20. So you have another value also at 20 later. Okay. So for amplitude, it will be 5.1. So it is a bit high. 5.1. Okay. And then here is 20 is 20. What is the angle? Is 11.3. So you have is it 11.3? Oh, sorry, tak nampak. I tak perasan. Okay, so this is 40. Okay, 40. Sorry, I didn't see it just now. Okay, if you see this one is 40, okay? You have 40 here. So 40 need to be minus with 11.3. So what do you have? Sorry, silap sini. Okay. 40 minus 11.3. What you have? Because you have 40 here, you need to minus 11.3.
28.7.
28.7.
Yeah.
Okay. So it's 28.7. Thank you. Okay, 28.7. So each here should be 28.7 degree. Okay. So this is how you get your answer for that. Okay. Let me screenshot first. Okay. Screenshot for you guys to be in your slide later on. Okay.
Doctor,
Hmm.
theta n kan equals to negative 11.3 kan?
Hmm.
So for the operation, we should 40 still minus 11.3 or 40 minus negative 11.3?
Okay. Ya, minus slide tadi. Mana slide yang gabungkan tadi? Okay, this one. So actually kan sebenarnya dia actually it is 40 degree kan? 40 degree. We already have 40 degree there, and you just plus with whatever there. Whatever there is actually theta n. Okay, theta n is in negative kan? That's why 40 plus negative. Faham tak? 40 plus negative. Yeah. Okay. So any other question? Okay, thank you for the question. If you guys have something that you don't understand, just ask. Okay, no problem. Okay, next is next question. Apa lagi? So represent the signal in the form of complex exponential Fourier series and sketch the frequency spectrum. Okay, you see it mentioned here frequency spectrum, and this one is single-sided spectrum. When it's mentioned single-sided, single-sided. Okay. So this sketch, this one is mostly exponent. So it's mentioned here. Okay, question can be tricky. Sometimes they tell you, sometimes they don't tell. Okay, so when they told you exponential Fourier series, okay, most probably and maybe 99% is actually double-sided. Double-sided. So here you see 1A they mentioned single-sided, but section question number B didn't mention whether it's single-sided or double-sided. But you need to know. Okay. Here it mentioned here is exponent. So when it's mentioned exponent, it means it is a double-sided. So it's self-explanatory, but students should know the hint. Okay, should know the hint of that. Okay. Next we go to the next pen. Okay. Okay. The second question just now is about what? Okay. Second question, represent the signal in the form of complex exponential Fourier series and then sketch the frequency spectrum. Okay. So we use new drawing. Okay. Mana tadi soalan dia? Okay, I have to retype again. Panjangnya soalan ni. Wait. Okay, so the next actually we represent in the complex exponential GT 4 plus 3.4 cos 10t. Okay, I'm rewriting the question. Sorry, terrible handwriting. Nothing I can do. Don't have talent. Okay, 40 degree. Okay, this is for 20t plus 40 degree. Okay. Okay. Now we need to convert our signal into exponent. Okay. So Euler's theorem, what we have learned from Euler's theorem is that okay, we learn from Euler's theorem, using Euler's theorem from a naught cos omega t plus theta naught. Okay, we using Euler's theorem we can convert into complex exponential form. Okay, which is this one. Okay, a naught over whatsoever is this. Okay, this is a double-sided spectrum. So you need to remember this formula. Okay, I think it will be handful if you remember. Okay, it's not really difficult to remember this thing. Okay, and so we go for the okay. So here is 3.4 as 1.2 can be add. Okay, we try to settle this first. It's actually 4 plus berapa tadi? 5.6 rasanya. 5.6. I think cos. Is it 5.6? I think 5.6. Wait, mana calculator? Just now is what? 3.2 plus 3.4 plus 1.2. Okay, 4.6 betul lah. Okay, 4.6. 4.6. Not 5. 4.6. Okay. Cos 10t dalam ni. Okay, inside here. Okay. And then you have whatever. You have sin 20t plus 40 degree. Okay. Sin 20t. And then you have 5 cos 20t plus 40 degree. Okay. So the next is you need to convert this one to complex exponential form. Okay, complex exponential form. So you see 4 plus 4.6. Okay. Now you have to introduce Euler's theorem. Okay, Euler's theorem. E J. You see it is 10t. So you just use 10t. Okay, and then plus if E negative. Okay, remember negative. J 10t. Okay, and then Euler theorem also stated that it is to be divided by 2. Okay, finish with our one terms. Now the next one is sine. Okay, sine also can be converted, but remember sine you will have 2j. You have 2j below. Okay. But we have settled this before. Okay, we have settled this before. Sine 2t 20 plus 40. Okay, is actually equals to what just now? We have settled for them before. It is actually 5.1 cos 20t plus 28.7. Okay. Okay, this one, this whole thing is actually something that we have solved before. Okay. we have solved in the previous example. Okay, yeah, saya nak tengok balik. So it is actually 5.1. Okay, 5.1 cos 20t, okay, plus 28.7 degree. Okay, this is the addition of these two just now, sine and cos. So now you have 5.1. Okay, we use Euler's theorem. Okay, so you have now E, J, okay, you have EJ, then masukkan dalam. So you just put inside 20t plus 28.7, okay, 28.7 degree like this, okay, and then plus if E negative, remember there is negative here. Maybe I should put different colors so you guys never mind, you can just can see there is negative, and then J 20t plus 28.7 degree, okay, something like this, and then divide by 2, okay, divide by 2. So simplifying this, 4.6 is actually 2.3, 2.3, so 4 plus 2.3 EJ 10t, okay, and then plus 2.3 E negative J 10t, okay, you open the bracket, okay, and then please and then this one 5.1 divided by 2 is actually 2.55, okay, and then you open this bracket, then you have E J 20t plus 28.7, okay, and then you plus with another one 2.55 E negative J 20t plus 28.7 degree, okay, 20t. So now you have a complex Fourier transform, complex Fourier series, not Fourier transform. This one you will study later on, transform. Okay, now you have complex Fourier series, okay, complex exponential Fourier series, double-sided, okay. Now you need to actually to plot the sketch, then you need to sketch the frequency spectrum, okay, you need to sketch the frequency spectrum. So we have this, okay, first you need to have two kind of graph, okay, this is the amplitude, and then you have the phase, okay, phase spectrum. So omega, this one is your amplitude, okay, and this one is your theta, phase spectrum, okay. So remember, you should all have this, and this is basic, you need to plot properly, the axis, okay. So first is 4, no angular, okay, just here, so it is here at 0, so this is 4, and then what is the angle? Is 0, so certainly it is here, okay. Next you have 2.3, okay, you have 2.3, you have 2.3 with the 10 there, 10, so omega here is 10, so you have 10, then you have another one negative 10, okay, so mean here also you have 10, then negative 10, okay. For the amplitude it is 2.3, so a bit small, 2.3, and here is 2.3, okay. Next, how about the phasor? It is you have 0, okay, you have 0, you don't have any phase shift here, 0 shift, so it is 0, okay. The next is you have 2.55, okay, at 20t, so 20, negative 20, 20, negative 20, okay. Then you have you need to see the magnitude now, it's 2.55, so it's a bit higher, okay, 2.55, not really to the scale, but I hope you guys understand. So this one is 2.55, Okay. Next, we need to settle for, needs to see for 20, what is the phase difference? We have here is 28.7. Then we have here is 28.7 with minus. Okay, with minus. So this is 28.7 here. And the next one with minus. Okay, with minus negative 28.7. So going below here. Negative 28.7. Okay. Right degree, for me it's a bit inconvenient because I'm using touchscreen. Remember, just write degree. This one is not degree. This one is omega. The degree part here, you need to write it with degree, okay? So this is where you see this is double-sided spectrum, okay? You can see this is, both of them is double-sided spectrum, okay? So this is a complex Fourier series, okay? So let me take this also. I would suggest you guys to try yourself at home. Try yourself, and you try to see whether you get the same answer as me. Okay, whether it's good for to check whether you understand or not, or maybe I have made a mistake in my while explaining the example. Okay, either way, you will learn if you try. Okay, so I suggest you guys try first. Okay, you guys try, and whether you guys get the same answer with me or not, because you will learn how to convert. Okay, if you didn't learn how to do it, then you don't know what you don't know. That is more problem. Okay, you don't know what you don't know. Okay, where were we? Sorry. So we go to the lecture slide now. Okay. Kejap bateri saya nak habis kejap. I need to plug in my charger. Okay. Where were we? Sorry, where were we? Okay, okay, now I'm sharing the screen for the lecture slide. Okay. Okay, sharing the screen for lecture slide. Okay. Okay, you guys can try this. You guys can try this at home and then see if you get the same answer. Okay. I think you guys need to try. Okay. And then what else? Example 2, for the continuous time periodic signal represent the signal in the form of complex exponential Fourier series. Sketch the double-sided frequency, magnitude and phase. Okay, so example 2, I will, you can do at your own. Okay, you can do at your own. I don't know why it's not charging. Is it? Okay, example 2, you can try at your own. Okay, there is answer here. Okay, there is answer here for example 2. Okay, there is answer here. Try to see if you get the same answer or not. Okay, so there is answer here. Okay, there is answer here. You try first for the example 2. Okay, next is the Fourier series periodical signal. Okay, so you see periodical signal. So when you see periodical signal, means it is repeated. Okay, so repeat itself at equal interval of time t naught. So t naught is actually the complete period. Okay, complete period of t for one cycle. So you see here is vt plus minus n t naught, where naught is actually 1 over f. I think this one is everyone already familiar with, and you have n integer. You see, we can have all sorts of shape of periodic signal, whether it is sine, square wave, triangle, and sawtooth. Okay, if you want to represent periodic signal in the frequency domain, okay, we represent it in the frequency components. We call it spectrum. Okay, spectrum is actually the way we represent our signal, which is initially in periodic signal in terms of frequency domain by its frequency components. Okay, so that's what we call as a spectrum. Okay, so Fourier series representation. Okay, Fourier series representation can be represented in two forms, whether it is in a trigonometric and complex exponential. I think you guys saw just now. Okay, trigonometrics. Okay, and complex exponential. Okay, so you can represent in two forms. Okay, so you have this is the periodic signals. Okay, you can see it's periodic repeated. Okay, if you can see, this one is in the time domain. Okay, you see it's t. Okay, this is volt. Okay, this is in the time domain, but later we will see it is in the frequency domain. So you need to be very sensitive or aware what is the value. Okay, sometimes t. Okay, this is sometimes is a simplest careless mistake. Okay, but if you didn't see this, maybe you're not aware. Okay, it is time or whatsoever. Okay, so Fourier series, trigonometric Fourier series, complex exponential Fourier series form. So what is Fourier series? Okay, representation of complicated periodic signal in the frequency domain. Okay, it is complicated in the sense that if it's we going to solve it using periodic signal, it will be complicated. So that's why we try to solve it by having to solve it from different view. Okay, still the same thing, but different view, which is the frequency domain. Okay, by its frequency components. So the representation of musical sound as a sum of wave of various frequency is an audible example. So you can see, right, when I think maybe sound, we always refer to like different frequency. Okay, different frequency. But actually, this sound is also a periodic signal, which is time. But it is easier if we describe it using frequency. For example, someone sing, right? Maybe the frequency change. Okay, the frequency change. Also, like when well communicate with each other, we describe using frequency. Okay, the means of signal they have, way of transmitting signals. Okay, trigonometric Fourier series. Okay, this one is FS, is Fourier series. Okay, periodic signal can be written as infinite. Okay, you see here the word infinite, cosine and sine function. General form of Fourier series. Okay, Vt equals to a naught over 2 plus summation of from n equals 1 until infinity. So if you see this one is n1 until infinity, so it's what? It is from, you need to see this range later on. Okay, some will be like negative infinity. Okay, some will be start from 1. So there is implication of that. Okay, so a n cos n omega not t plus b n sine omega not t. So if we are going to expand this, okay, expand it means expand this sigma summation, you have a naught over 2 n1, you have a1 cos omega not t, and the counterpart b1 sine omega not t, which is this. And then you have n2, you have a2 Okay, A2, then you have cos 2 omega not t, and then you have sine omega 2 not t for B2, and so on. So A2, A naught over 2 is actually your DC current. Okay, DC current means the value that this fixed. Okay, and then you have AN plus AN and BN Fourier current coefficient, and then you have omega naught, which is fundamental frequency. Okay, and then you have n omega naught, we have harmonic frequency, n 1 2 3 4. This one is depends. Okay, let's say the question give you up to 5, then your n is 5. Okay, this is your n, so it couldn't be you solve until infinity, right? Otherwise how can you answer question? Maybe they will give like 5 n5 n6, something like that. Okay, is it clear? Is it clear so far? Is it clear? No, in Google Chat, no one respond. Otherwise, I should sendiri as lecture and assume student understand. Maybe student actually, what the hell is he talking about? Okay. Okay, understand. So far, so good. But I think no problem. So far, my section is quite. I think it's. I try my very best. I try my very best. I give lecture. I prepare lecture, and then I record my lecture. So if you think that you don't understand, no problem. You can replay. Okay, you can replay my live lecture. Okay, so long that you don't share it to outside network, because recorded live lecture. I'm human, Sometimes human make mistake. Sometimes I mistakenly say something that is sensitive. So that's why. Please don't share. Okay, this is just for you. Okay, but I'm not perfect. Okay, sometimes I give lectures. Sometimes I saying something that is not correct or inappropriate. Okay, so trigonometric Fourier series, to plot the frequency spectrum, frequency series should be represented by, you can see here, Vt plus A naught t over 2. This is your DC current, and you see sigma started from 1 until infinity, an cos n omega naught t plus theta n. So if you see, I say just now, right, there is implication whether you start from negative infinity or you start from 1. Okay, if you see here, you start from 1, you didn't start from negative, mean you will have answer at one side only, which is single-sided spectrum. That's why it is single-sided spectrum. You can see, right? It started from 1 until infinity. We don't have negative. Okay, and then where theta n is a tangent, inverse tangent of negative bn over an, and an is actually an square plus bn square. Okay, so Fourier coefficient an and bn can be obtained by integration. Okay, an a naught plus 2 over t and so on. Okay, this is how you're going to have your an and bn. Okay, an and bn. So luckily, you guys didn't have to if I'm not mistaken, you guys didn't have to do this integration. You just use the table that we provided to solve your solution. Okay, to solve your problem. So it's lucky to you guys, huh? If not, if I'm not mistaken, during my batch, we do integration. Okay, we do integration, and with our time when the technology is not really advanced, okay, we do just calculator, and so you guys should, maybe, I think if I were you, I will be grateful, because syllabus is easier. During my time is heavier. Okay, so maybe our batch is uh, you know have more heavy syllabus, but it's okay for me. It's good. I learn more. Okay, so I learn more. Okay, we do the integration, but now you guys just use the table. Okay. So that's why sometimes maybe students say, "Oh, it's difficult." But maybe you guys didn't realize the earlier batch, they actually have more syllabus, more heavier syllabus. But a bit that I see notice a bit different during my time. During my time, okay, I don't compare with my with new time. During my time, we just follow whatever the lecturer, okay, and we don't have complaints, okay, and even that time Facebook is not really, no one really use it, but we don't compare, we just follow whatever lecturer, we just follow, we respect lecturer, we just follow. And if lecturer require our response, we just give response. Okay, no problem. Okay. And then during our time, if my not mistaken, 80, we don't have A plus A minus. We don't have A plus A minus. 80 is considered, 85 only consider A. So you can imagine, maybe let's say maybe newer batch for flat, maybe for flat. But if you go into our time, maybe it's not for flat. Maybe you only 3.6.7, something like that. Because during our time, there is no A, and A is only start from 85. Okay, if you 80 until 85, 80 until 84, you maybe around, you are B, something like that. So last time is more strict, but it's okay. Industry no, so they appreciate last time. They know UTM strict, so better quality last time. Okay. Um, so you see here, A naught is merely the time average of VT. It is 0 if it's symmetry in the period of time T. You see here, A0. Okay, A0 is merely the time average of T. If you have signal which is symmetry in the period of T, symmetry means, you have symmetrical signal. So your A naught is 0. Okay, your A naught is 0 if your signal is symmetry. Next, Bn. Okay, Bn here, okay, is different. This one is A naught is actually, we need to see A naught is actually what? Here. Okay. Next, we're going to see our An here, okay, or An, or which is consists of Bn or An. Okay. So this one is A naught. So different. Okay. Hope you guys see the difference. Okay. Next, Bn. Now Bn is 0 if Vt has cosine wave, cosine like even symmetry along the time axis about T0. Okay. I think you see, right? The cost graph is actually like this. How? Okay, like this. Okay. So they are what? They are even, right? They are even or odd symmetry. They are even or odd symmetry. Cosine signal. They are odd or even. Odd or even symmetry for cosine. Can you guys answer? Whether odd or even symmetry for cosine. You learned this in the earlier lecture where we learned about odd symmetry, even symmetry. Okay, so it is even. So it's even symmetry because it is identical. It is identical from here, this part and from this part. Okay, so Bn is 0, has cosine like even symmetry. Okay, if Bn is 0, if we have even symmetry. Okay, next, An is 0 if Vt, okay, have sine like odd symmetry. You see, sine like odd symmetry along the time axis. Okay, now is An. I think now, odd symmetry, I think you guys also know. Okay, odd symmetry is actually like anti-symmetrical. So sine wave is one of the odd symmetry, anti-symmetrical. Okay. See, if you have positive, then the counterpart is negative. So sine wave is actually the odd symmetry. So if you have odd symmetry, which is sine like, your An should be 0. Okay. And then the next, An equals to Bn equals to 0 for all even value. For all even value, if Vt has Q rotational symmetry. Okay. Successive half period, half mirror image. So you can see skew image, okay, skew symmetry. An equals to Bn equals to 0. So there is actually various condition where An, Bn, An or A naught will become 0. Okay, you need to be to simplify your calculation. Okay. So you see here, frequency series symmetrical properties. Okay, frequency series symmetrical properties. Example, you have A naught plus 2. Okay, from n1 equals to infinity and so on. Okay, then you can see actually you have cos and you have your B sign. Okay, AN plus BN. And you can see this one is actually you can combine it later on. Okay, later on you can combine it become AN. Okay, AN, but and then inverse tangent. Okay, so here if signal VT is an even symmetry, okay, even symmetry in the period of time which is your horizontal axis, the equation for Fourier coefficient can be simplified and become, okay. So here is even symmetry. Okay, you see previous case even symmetry. Where is even symmetry? This one. If even symmetry, your Bn will be 0. Okay, that's why your Bn here is 0. Okay, Bn is 0 for n whatever. So Bn is 0. So if it's this 0, so you already remove this. Okay, you already remove this, left with a naught over 2 plus cos. Okay, plus cos. Then this, and then a naught over 2 okay, a naught over 2 is merely a time average. It is 0 if it's symmetry in the period of time t, because just now is symmetry, right? So your a naught is 0. Okay, so your a naught is 0. 0 over 2 is 0. So that's why you start from you have 0. Okay, then an you have the integration of this, but this one you just solve using table. We provide you table later on. Okay, you don't have to do the integration. Okay, good for you. Okay, hopefully less complain whether it's question is difficult or not, I'm not sure, but my batch we integrate. Okay, my batch. Okay, next, if signal is odd symmetry. Now we have odd symmetry, which is like this. Okay, in the period of time t, the equation for Fourier coefficient can be simplified and become, if it's now is odd symmetry. Okay, odd symmetry, where is odd symmetry? Blah, 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 blah. Here, odd symmetry. If it's odd symmetry, an is equals to 0. Okay, so now is your an is become 0. Okay, and then your n 0 is we have symmetrical. Okay, if we have symmetrical along the time axis, a0 is 0 over 2. Okay, so now you have a naught 0 and you have a naught an 0. Okay, means that you have this as 0, this is 0. Now you settle for bn. Okay, now you have bn integration of this one. Okay, integration of this one and 1 of 2 3. Okay, but you solve this using table. Okay, so you get these answers. Okay, the next is example, trigonometry Fourier series. Find the trigonometry Fourier series for VT until fifth harmonic. Okay, so you see here, they mention fifth harmonic. So you will not solve until infinity, right? It's impossible. So they mention until 5 harmonic. So until n equals to 5. Okay. Where is just now with the this one. Okay. You see here, you see from 1 until infinity. Okay, from 1 until infinity. So you can this one is for the case of single sided. Okay, the question didn't mention just now. 1 2 3 4. But you see here, okay, if it's mentioned until 5 minutes, mean n1 equals until n5. Okay, I just not sure what the question one. Sorry. Okay, so this is not the answer. This is actually to show you the signal. Okay, if you see this one, okay, you need to provide the trigonometric signal. Okay, you can see from the general equation, this is the general equation. Okay, the general equation. Now let we see first, is it this one is odd or even signal. First, you need to know this. Odd or even signal. Okay. Odd. Okay, only Hanisa. Okay, it's odd. Okay, so means this one is odd signal. And this one is symmetry. Means your A naught will be 0. Okay, your A naught will be 0 because it is symmetry. And second, it is an odd symmetry. If it's odd symmetry, where is this? If it's odd symmetry like this, okay, odd symmetry, your AN will be 0. Now you need to settle with BN. Okay, you now need to settle with BN. Okay, you need to settle with A0, A0 will be 0 because it's symmetry. And then because it is odd, so your AN will be 0. Okay, AN will be 0 because it's odd symmetry. So you're left with BN. So you need to settle with BN. Okay, you need to settle with BN. Okay, you need to settle with BN here. Okay, you need to settle with your BN because now this one is 0, this one is 0, and this one can be settled using table. Okay, so they give you example. Okay, they give this is actually 20 millivolt. This is actually the amplitude. Okay, this is actually the amplitude. Okay, next, complex exponential Fourier series. Okay, whenever they mention complex exponential Fourier series, mean you need to use Euler. You need to use Euler equation. Okay, or Euler theories. Okay, to spread it. When you start to have complex exponential, means you will have a double-sided. Okay, you will have a double-sided results. Okay, spectrum. So you see, this is your original Fourier series. Okay, original Fourier series. So cos n omega naught t, and you have ej whatever, and sin n omega naught t. Okay, if you see, there is different with the previous Euler, where we have n inside. Okay, we have n inside. So bear in mind, you see, you need to see where there is n here. There is n. So there is n here. Okay, so you have jn, so n. And remember, different with cos and sine is that sine will have 2j, and cos here only have 2. Okay, only have 2. So if we to convert to complex Fourier series, okay, if you have complex Fourier series, so you have n naught over 2 with n start from 1 infinity. Okay, so you can see, sorry, just now I a bit mistake. I say it's double-sided, but it's not. Sorry, where is the previous equation? Okay, we start from 1. Okay, we start from 1. Okay, so n naught over 2 and 1 until infinity. Then you have an cos n omega naught t plus bn sin omega naught t. Then you have your vt. Okay, n naught over 2. Then you have infinity. Ejn omega naught t. Okay, you just include that jn omega naught t, negative jn omega naught t. Okay, because now you have n inside. Okay, because you see from the previous formula, you have your n. Okay, you start to have your n inside here. Okay, that's why you start to have n here as well. Okay, when you have n, you need to just substitute it accordingly. Okay, then jn omega naught t. Okay, this one is the Euler formula. Then 2j, and then further expand. This one is stays the same, and then further expand. Actually, an jbn over 2. Okay, ejn omega naught t. Okay, you need to isolate. Okay, this ejn omega naught t together. Okay, you can see here, factorize it, and then the next one with negative j omega naught t, you factorize it with its partner. Okay, so this one is an minus jbn. Okay, minus jbn ejn omega naught t. Okay, this one is an plus jbn over 2 for e negative jn omega naught t. Okay, so for complex Fourier series, this first term will be a label like c naught, and this one is cn, and this one will be your c minus n. Okay, y is minus n, you can see here, right? This one is the positive. Okay. Next. Now your VT, okay, VT has been simplified. Okay, complex exponential Fourier series has been simplified. Your VT become using Fourier series. So you see VT equals to C naught. You simplify it further from the previous slide. Okay, you have Cn Ejn omega naught t and C minus n Egn omega naught t. So this is further simplification, where Cn is a complex conjugate of C minus n. You see, Cn is a complex conjugate of negative n. I think you learned in your secondary. Okay, in Malaysia level, I'm not sure. In Malaysia secondary, I'm not sure in other syllabus, Indonesian or foreigner. Sorry. Maybe you guys can share with me, because it's your education system, you know better than me. So you see, it's complex conjugate. Complex conjugate is like you have the same magnitude, but you have a different sign. Okay, so this one is negative Cn, and this one is negative C negative n. Okay, hence complex Fourier series can be simplified further. Okay, with his equation. If you notice now, just now we have n from 1. Okay, now we have n from negative infinity. Okay, because we simplify the negative Cn here further. So we have negative infinity until infinity. Okay, so Cn Ejn omega naught t. So we consider we further simplified. Now instead of having n1 below, now we have negative infinity because we consider the complex conjugate cases. Okay, so then where Cn equals to 1 over t, integration t over naught Vt e Jn omega naught t dt. Okay. Okay. So this is actually given. Okay, this is actually given. In your final exam paper, I think it's given. Okay, should be given because you will solve this. You will solve the question problem solution using this equation. Okay, first let me see number 1. We see number 1. This is your trigonometric form. Okay, this is your Fourier series, and this is your properties. They even mentioned here. Okay, you just the challenge is that now you have the table, but you need to understand what is it. Okay, you need to understand what is it and how to use it. Okay, this one is mentioned in this slide also. And then here is combined trigonometric form. Okay, combined trigonometric form is that you see this form. Okay, you see this form. Now we combine them, combine cos and sine. Instead, now we have cos only. Okay, we combine them. You see, this is the way to combine. A naught is actually a naught over 2. Here you see a small letters over 2, and then an is actually an square plus bn square, an square plus bn square, and then tangent. So this is the combined form. Okay, where a capital not is average value, a capital an is 0 for n even if ft is a skew function. Then we have exponential form. Okay, this one is you see from the last slide just now before this slide. So you have this here, you see negative infinity. Okay, and this is your Cn. You see here, this mentioned negative t over 2 and t over 2. Why? This is to be complete period. You see, this is 1 over t. This t is complete period, and then negative t over 2 until t over 2. This one is also 1 complete period. Okay, C naught average value, Cn real for even, imaginary, and Cn equals to 0. I'm not sure the tutorial that I shared to you guys, is it already touched about this or not? The tutorial with no answer. I didn't really check until the end. I think we didn't touch. I think that tutorial didn't touch on this chapter 2. Okay, because the tutorial before is chapter 1, if I'm not mistaken. Am I correct? You don't have this right in your tutorial. Don't have, right? Any response? No response. I think you don't have tutorial. I didn't think tutorial have only touch until chapter 1. Okay, this is chapter 2, so you don't have tutorial. I think later on, when you later on, I will see if we have tutorial. Okay, then you can see the the difference. Okay, you can see how to use it. Okay, later on, Adi, please ask your fellow mate, okay, when we can have tutorial, because you will miss one tutorial compared to other section. Okay, at least for my section, section 4, they will have tutorial tomorrow, so they will have tutorial but you guys don't have. So you guys need to have replacement, otherwise it's not good for you. Okay, because you're going to benefit. Tutorial is like exercise section. Okay, so Adi, please ask your friend when is the tutorial. Okay, the replacement tutorial, because you don't have class from you don't have class on Wednesday and Thursday. Okay, maybe you guys can ask. I'm not sure with my schedule. Okay, I stop my lecture. Okay, but I mean I stop my recording.